All right. So, can I get you to turn off the front bank? Thanks. Okay. So we're going to be going over essentially the two types of quantities that we might work with in physics. Okay, scalar quantities and vector quantities. We treat them similarly, but they look at the same things in slightly different ways. All right. So what we want to look at is essentially the type of quantities that only have a magnitude. Okay, so they only tell us a number with units, okay, versus the kind of quantities that have not just a number with units, but also they tell us what direction the object is going. Okay, so vector quantities have both. Okay, vector quantities have a magnitude like 20 kilometers, but they also have direction. Okay, and that would be like 20 kilometers north. Okay, everybody with me there? All right. Now, the first thing that we have to understand is that we as North Americans do not understand the idea of how to measure things or how to give information when it's asked. Okay, I'll give you an example. I will ask Omar, how far is it to Edmonton? Okay, at least you asked. Okay, most people would just automatically. How many of you were thinking 3 hours? Most of you are thinking 3 hours. What did I ask? How far is it? I didn't say how long does it take. I asked how far is it. But that's how we as North Americans think. Okay? When someone asks how far is something, we tell them how long it takes to get there. It's not right, but we do it. Okay? But it's because of our lifestyle. Our lifestyle and the way we transport ourselves from place to place is we get in the car, we get on the road, and as long as we can go the speed limit, we know how long it takes to get to a certain place. Here's the problem. Today, it would probably take longer than 3 hours to get to Edmonton, okay? Because the roads are treacherous on a few sections of Highway 2 on the way there. So today, it's not 3 hours. But you know what? It's always about 300 kilometers. No matter how bad the roads are, it's 300 kilometers from here to Edmonton. I mean, it's about 300 kilometers. Okay, everyone follow me there? I want to give a measurement that doesn't change. Okay, I can give that measurement. It is independent of how fast I can drive or the road conditions or anything else. Does that sort of make sense? Okay, so we have to get past this kind of ingrained thinking that we have when we get into physics and start talking about the quantities and measurements that we're going to make. Okay, now the example we just did with the thing to Edmonton, okay, is very much like this example here. If you've ever gone hiking off trail or done orienteering or anything like that, how we describe travel in everyday life is only effective at getting you hopelessly lost in a roadless or trackless environment. So even if someone had told me it's 300 kilometers from here to Edmonton, what if I wasn't from here? Would that help me? Nope. Because how many choices do I have for which direction to go? 360. Right? If I stand right here, I could go that way. I could move 1 degree this way and go that way. I could move 1 degree, and I could do that 360 times before I got all the way around the circle, right? Okay? Probably only 2 of those would end up meeting up with Edmonton after 300 kilometers, okay, if I was lucky. All right? So, yeah. That wouldn't be very good. If I was like, let's say, a helicopter pilot who had no idea where Edmonton was, I shouldn't be a helicopter pilot then, but okay, if I was, I would have 360 choices for which way to go to get there. Now, if I said 300 kilometers north, that would be more useful. Okay, then I would know essentially which way to go. But I'm saying roadless, trackless, no GPS. Okay, you don't want to just depend on a GPS. Take it from me. I did that one time on a hike. Okay, on a backpacking trip. One time, didn't bring a paper map, just brought the GPS. Got it wet, dead. Okay, now how do you get from place to place? Okay, now you have to do it the old-fashioned way, the really old-fashioned way. All right, the river flows east. We'll follow the river until we get to some place, and then we can figure out how to get home from there. You don't want to be in that situation. Don't depend entirely on a GPS. All right, you never know what might happen. Okay, so if I'm right here on this map, okay, and I'm here at Seldom Inn Campground, okay, which is what this is called, Seldom Inn because there's seldom anyone there. Okay, when we got there, the grass was waist high. Right? No one had been there in a very long time because you have to hike about 35 kilometers to get to it. Okay, from there, we wanted to get to Snake Indian Falls Campground. Right? What would be the most logical direction to go? Okay, the little hash marks, by the way, are trails. You guys are thinking way more than you need to. Follow the trail? Okay. Right? That would be the most logical way to get there, right? Follow the trail. Right? And that's what most people would assume. That's why the sign outside of Seldom Inn Campground says Snake Indian Falls Campground, 27 kilometers. Okay? It makes the assumption that you are going to follow the trail. It gave me a scalar description of where Snake Indian Falls Campground was in relation to Seldom Inn Campground. Right? It made the assumption that I would be smart and stay on the trail. Okay? Would it have given me a different description if it had wanted me to go as the crow would fly, and that would be along that line? It certainly would have. Okay? It would have probably had to say that now it's, I don't know, it's probably less distance, probably maybe only 23 kilometers maybe. Okay? And it would have been, let's say, 60 degrees west of north. Something like that. All right, so I would take out my compass, face north, and then turn until it was 60 degrees off and start walking in a straight line. Is that difficult? Yes, it is. All right, I mean, if you look at this map, there's rivers, which usually are in canyons, okay, glaciers, and other manner of disaster in a straight line between these two places. All right, so it would be more logical to give someone a scalar description in a case like that. And that's why all of the road signs in Alberta give you only scalar descriptions. Okay, when you get on the road here, okay, and you're headed south, it tells you Lethbridge is 160 kilometers. It doesn't tell you it's 160 kilometers 10 degrees east of south. Okay, it doesn't need to tell you that because it knows that you're going to stay on the road. Agreed? So there's time and place for both types. Okay, if you're a pilot or you're the captain of, let's say, a cruise liner, then you've got to get vector descriptions. Why? Right. You don't have a road to follow. Okay. As a pilot, you can't follow a road from, let's say, Toronto to London. And I don't mean London, Ontario. I mean London, England. Okay. Everyone follow me there? I have to fly over the ocean. There's no road that runs directly from one place to the other. So I need to know what my heading has to be. That's what a vector is, like a heading. So, I might have to go, let's say, this is going to test my geography skills, 40 or 50 degrees east of north and head that way. Okay, something like that. And that would get me maybe there. All right. If I'm a captain on a cruise ship or something like that, same idea. I've got to have a heading that gets me from one place to the other. And that's assuming all things go well and I don't have to fight anything that might push me off course, like wind or ocean currents. Okay? Does that make it even more difficult? Yeah. Okay? That's why you generally have to be pretty good at math to become a commercial airline pilot. All right? They don't just say, they don't need to do math anymore, they got GPS. When you got a plane full of passengers and the GPS goes out, they want you to be able to do the math. Okay? Because people get kind of upset when planes crash. You may have noticed that. All right? Okay. So, when we say Calgary is 40 kilometers away, we make no reference to which direction. Okay? So is that a scalar quantity or a vector quantity? Scalar. Haven't given a direction. Okay? Is it useful? Sure it is. Is it accurate? Sure it is. Okay? It's probably plus or minus 1 kilometer. Okay? It's 40 kilometers plus or minus 1 kilometer from where we are to Calgary, to city center in Calgary. Yeah. Okay? That's a pretty accurate description. All right? Is this any more accurate? Whoop. Let's say 13 degrees, I think it is. Okay, 40 kilometers at 13 degrees west of north. Is that any more accurate? Is that 40 kilometers at 13 degrees west of north. Is that any more accurate? It's more descriptive. It's not more accurate, though. Okay, it's equally accurate to this 40 kilometers, right? Now, if I'd have said this is 40.0 kilometers, would that be more accurate? Yes. I've measured it to a greater degree of accuracy. This 40 is only measured to plus or minus 1 kilometer. This is measured to plus or minus 100 meters. Okay, 0.1 kilometers. So this is more accurate. Okay, this, however, okay, is more descriptive. It gives me additional information, but it's measured to the same degree of accuracy. Everyone follow me there? A lot of people seem to get this idea that vector quantities are always more accurate, but they're not. They're more descriptive. All right. Okay, and then of course in here I've got more accurate, but I think I changed it in your notes, don't I? Does it say more descriptive in your notes? A more descriptive description? Does it say more descriptive in your notes? Yes, no? If it doesn't, change it. Okay, it should say a more descriptive description would be that Calgary is 40 kilometers away on a vector of 13 degrees east of north. Okay, that's a vector description because I've not only given the magnitude, how many kilometers, but I've also given the direction. Okay, now, for us in Science 10, we're not going to deal with degrees west of north and things like that because that would bring in trigonometry. Don't have to do any trig in Science 10 physics. You will in Physics 20, okay? But you won't have to do any trigonometry in Science 10. Our vectors will be what we call one-dimensional. Forward and backward, that's one dimension, okay? This is only one dimension. North and south, only one dimension. Up and down, okay? Right and left. They'll always be exact opposites. Everybody follow me there? Okay, so you'll never have to do any triangulation, okay? No sine, cosine, tan, or anything like that. Then don't worry about it. Okay, when we give a distance, okay, distance is a scalar quantity. Okay, displacement is a vector quantity. They measure the same thing, that is, how far it is from one place to another, but they do it from different standpoints. Displacement is a scalar quantity. Distance is scalar. Displacement is vector. All right. So if I am going from my house to Walmart, okay, I might have to follow. Make a bad drawing here. Let's say that my house is here and Walmart is over here. Okay, and I come out of my driveway and I got to turn, and then I got to, and maybe the road curves or whatever. Okay, and then I get to Walmart. Was I able to travel in a straight line? No, but I probably walked 4 kilometers, let's say. Okay, this path here measures 4 kilometers from my house to Walmart. So when I say it's 4 kilometers from my house to Walmart, that is how far I would have to walk to get there. Is that how far Walmart is in a straight line from my house? No, that's what displacement measures. Displacement measures this. How far I have displaced myself, not how far I've had to walk to actually go there. Okay, so this is the one that says you walked there. This is the one that says you flew there. Okay, and how you'd be able to do that. Everybody with me on that? So displacement is almost always going to be smaller than distance, unless you are actually able to walk in a straight line, and then they would be the same. Exactly. All right. So we got the 4 kilometer distance, but the displacement would be 2.8 kilometers, 38 degrees. Well, I didn't draw that very well. North of west. If we made this my home and this Walmart, then the diagram fits. Okay. All right. Everyone okay with that idea? Okay. So they both measure the same thing, but one gives you a direction. Now, let's say that it took a half an hour for me to walk from my house to Walmart. How fast did I walk? What units do we usually use for speed? 4 kilometers an hour. Okay. Now, what units? Okay, kilometers per hour is usually the units we use for speed. Kilometers per hour. Everybody with me there? Okay. That's distance divided by time. Here's your first formula for physics. Speed, which is abbreviated v, equals distance divided by time. So when we went 4 kilometers divided by 1/2 of an hour, we get 8 kilometers per hour. I mean, if I'd have kept walking, I would have walked 8 kilometers at that rate, okay, in 1 hour. Jane, can I have you close that door for me, please? Now, speed is a scalar quantity, because you can see here, I don't have any direction on this, do I? Right? Doesn't say which way I went, which makes sense. I used a scalar quantity to calculate it. Okay? I can't take distance, which is scalar, and suddenly calculate something that has a direction on it. All right? That's apples and oranges. But let's say I took my displacement and I divided it by the time. Okay? So displacement is a vector quantity, so we usually write it with an arrow over top. That differentiates between distance, which is just d, and displacement, which is d with an arrow over top. Okay? Divided by time. What's that going to get me? What's another word we sometimes use in place of speed that starts with v? Velocity, right? Okay? Velocity is the vector version of speed. So velocity equals displacement divided by time. Alright, so if I take my displacement, including the direction, and divide it by time, I should get my velocity. Okay? And that'll be 5.6 kilometers per hour at 38 degrees north of west. Should the direction be the same? It should, yeah. It would be impossible to travel at 100 kilometers per hour north by driving east. Agreed? So whenever you divide a vector quantity, that's what you're going to get, the same vector. All right. Okay. So velocity is vector, displacement's vector. Speed is scalar, distance is scalar. What's time? Time's vector or scalar? Scalar. Unless you know something I don't, and you can change the direction in which time flows, in which case you have a time machine at home, we can talk later. Okay? I'd like to go back in time and change a few decisions I made in my life. Okay? But time only flows one way. All right? We can't make it go backwards. All right? So time is a scalar quantity. We never have a direction on time. It's never 5 hours right or 10 hours left. Well, sometimes we say there's 10 hours left, but it's not a direction left. We mean how many are remaining. Everyone follow? Okay, so time is a scalar quantity as well. I don't have a less than, that's an arrow. Okay, the arrows we use in physics only have one tab on them. Okay, it's an arrow. Anytime a quantity or a letter has an arrow over top, it is a vector quantity. Acceleration, also a vector quantity. Force, vector quantity. Okay, things like that. All right, so this is what we were just talking about here a minute ago. Okay, speed and velocity are calculated in a similar fashion by taking the distance or the displacement and dividing by time. Okay, so velocity is a vector quantity as well. Right? Probably worth, okay, underlining those things. Okay, say speed's a scalar quantity. Now, if I go the same way home, okay, so if I walk exactly the same path, right? So I got to Walmart and I walked all the way back home. How far did I go? That went 8 kilometers. That's my distance. How far always is asking for distance, always asking for a scalar quantity. Okay? If it was 4 kilometers there and I followed the same path back, I would travel 8 kilometers. What would my displacement be? remembering that this is the definition of displacement. How far and in what direction you have gone from your starting point. So if I walk to Walmart and then all the way back home, my displacement is what? I started at home and I ended at home. My displacement is 0. Okay? Displacement is how far and in what direction from your starting point you have traveled. If my starting point and my ending point are the same place, I technically haven't gone anywhere. Okay? My displacement would then be 0. All right? What would my velocity be then? Velocity is displacement over time. If this is 0, what's this? 0, right? Anything 0 divided by anything is 0. All right? It would make sense. If I haven't gone anywhere, I can't have a velocity then. Agreed? Okay, so that's kind of the weird little loophole kind of thing that sometimes happens with vector quantities. Sometimes, if you come back to where you started, they end up being 0. Everybody all right with that? Okay, but my overall speed would still be, if it took me a half an hour to get back, would be 8 kilometers per hour, because I would have gone 8 kilometers in 1 hour. Okay, 4 kilometers there in a half an hour, 4 kilometers back in a half an hour. That's still 8 kilometers per hour. All right. So I want you guys to try this question here. I'm going to give you a couple minutes on that, and then we'll go through it together. Okay, this trip has 2 parts. Okay, that's what you got to keep in mind. Right? It travels 100 kilometers north in 1.2 hours, and then goes 62 kilometers south in 0.9 hours. Okay, so I want you to think about that. Remember, velocity is displacement divided by time. All right, so here's the first thing we got to remember. The formula we just learned. That velocity is displacement over time. Okay, we can add something to this and go average velocity equals total displacement over total time if we're dealing with a trip that has more than 2 parts. How many of you were looking at that and going, if I find the velocity for both parts and then add them together and divide by 2, I'll have it? How many people are thinking of doing that? Okay? And I understand that that's the way you've been taught to calculate averages up until now. It's still true, provided the things you're adding together represent equal parts of the whole. Are these 2 parts of this trip equal parts of the whole trip? One's 100 kilometers long, one is 62 kilometers. They are not equal parts of the whole. If I want to calculate class average for you guys on a quiz or a test, you're all equal parts of the whole. I add your marks together and divide by the number of people, and I have the average. I can do that for that part. For here, that won't work, okay? Because these 2 parts don't represent average. But what I can do is find the total displacement of the object by figuring out how far it ends up from where it started, and adding the times together and dividing by the total time. All right, so if it went 100 kilometers north and then came back 62 kilometers, how far is left? 38 kilometers. Okay, 100 minus 62 is 38. Everyone follow me there? All right, so we know the total displacement is 38 kilometers in which direction? North, because he went 100 kilometers north and 62 south, which means he didn't go as far south as he went north. The remainder is north. Okay, north. Divided by the total time. Well, the first part took 1.2 hours, and the second part took 0.9 hours. All right, so 1.2 plus 0.9 is 2.1 hours. Okay, then I just divide those 2, and I should get 18.1. Okay, kilometers per hour north. Okay, we always got to put a vector on a vector quantity. All right, does that look now as difficult as you thought it would be when you started it? Yeah, okay, that's usually the way physics goes. It usually is easier than you think when you first read it. All right. You'll see why I'm doing this in a minute. We're going to need to manipulate this formula. That is, do algebra. And we're going to have to manipulate for all parts, unlike with the mole equation. Okay? So, right now it's set up to solve for V. Let's say I wanted to solve for D. What do I do? Nope. Right, D equals V multiplied by T. Remember, there's two rules for algebra. Okay? Rule number 1. When moving something, okay, do the opposite operation. Okay, when doing algebra, when you need to move something, do the opposite operation. I'm trying to solve for D in this first situation. That means I probably want to leave D where it is because it's already on top. We always want to solve for something when it's on top. Okay, that means I got to move T over here. Okay, right now what am I doing to T? I'm dividing by it. So if I want to move it, I do the opposite, which is multiply. Okay, T times V equals D. Everybody with me there? All right. Now I want to solve for T. And remember, we just said we want to solve for something when it's on top. Where is T right now? It's on the bottom. Okay, so I would say the best way to get T on the top is to put it back where I had it a minute ago. Put it over here. Now it's on the top. But I want it by itself. So what do I have to do with V? Divide it, because right now I'm multiplying T times V. So I divide V over to the other side, and I've got T. Okay? Everybody with me there? All right, so the first rule is when you want to move something, okay, you do the opposite. Okay? The other rule is not rule number 1, rule number 2, okay, is what you do to one side, you do to the other. All right, so when I was moving these things around, what I was really doing was multiplying both sides by T. Okay, when I did that, I had a T on the top and a T on the bottom, so they cancel, and I'm left with T times V equals D. Everyone follow me there? Okay, when I moved V over to the other side, okay, I divided both sides by V. Okay, and it came over to that side. Everyone with me there? Okay, so what I do to one side, I do to the other. All right, that's kind of a 1A, because I want to say there's still only 2 rules. Okay, if you have to move more than one thing, okay, okay, we'll say move what isn't attached first. That's a rule that's not going to apply to V equals D over T. Okay, I'm just giving it to you now. When we use some of our other formulas, the importance of that will come in. I just want you to have those 2 rules written down for now. Okay, basically it means that if you had like something up here, like D plus something on the top, first you'd move T because it wasn't attached to D. Okay, things like that. All right. All right. Everyone okay with the manipulation there? Okay, because this is the easiest formula that we are going to deal with in this unit. Okay, shortly we'll start dealing with this one. So if you are still desperately clinging to your triangle, which you shouldn't be, okay, but if you are, the rug will be yanked out from underneath you next week when we start talking about acceleration. You do not have a triangle for that formula. All right, so yeah, maybe you have a square or a pentagon or something. I don't know because I don't do shapes. I do algebra because it's better. Okay, and it works all the time. Okay. So, quick summary here. Scalar quantities have magnitude only. Okay, speed we symbolize with v. So you might want to write this part down. Speed is symbolized by v. It's a scalar quantity. Okay, d, distance. 65 kilometers would be an example of that. Mass is a scalar quantity, 75 kilograms. Okay, your mass is a measure of how much of you there is. That doesn't have a direction. That's just how much you are. Okay, time also scalar. Okay, 4 days. Okay, vector quantities, they have magnitude and direction. Displacement, velocity, okay, are our vector quantities. Acceleration, which we'll talk about next week. Could that be an easy multiple choice question? Yeah. Which of the following are scalar quantities? Okay. Or which of the following is a vector quantity? Something like that would be an easy multiple choice question. All right, and then we've got these formulas here, okay, and I'm going to give you your formula sheets probably on Wednesday. All right, since right now you only have v equals d over t to remember, all right, I'm sure you can remember that one. All right, I'll give you your formula sheet on Wednesday. Okay, anyone still need that? All right, and you can see here, guys, that I have these ones down at the bottom here. Average, okay, and this one should also say average. All right, so velocity, average velocity is like the one we just did. Total displacement divided by total time, and it's the same for speed. Okay, if you have a trip that has a bunch of sections and it asks for the average speed, you'll add up all the distances and add up all the times and go total distance divided by total time, rather than adding the speeds together and dividing by the number of speeds. Okay, that's just not going to work. All right, so do our first example here. Okay, so I've got a deer that can run 100 meters in 20 seconds. So it's coyote bait, because if it takes 20 seconds to do something a human being can do in 12, okay, it's a pretty slow deer. All right, but it runs 100 meters in 20 seconds. How fast is it going? All right. When you're solving a problem like this, it's very much like the mole equation. Write down your givens. Okay, because by the end of the physics unit, you're going to have a number of formulas to choose from, okay, and choosing the right formula is kind of important. So writing down your givens will help you to figure out which formula you're going to need to use. So it runs 100 meters. Is that a distance or a displacement? It's distance. Has no direction on it, so it's a scalar quantity. That's why it doesn't have an arrow over top of the D. 100 meters. In 20 seconds, that's time. Okay, how fast is it going? If it's asking how fast, it's asking for speed. If it says how fast and in what direction, it's asking for velocity. All right, so in this case, it's asking for speed. Well, speed is distance divided by time. 100 meters divided by 20 seconds. Okay, 5.0 meters per second. Right, so this is, like I say, a pretty slow deer. Okay, questions on how that one worked? Okay, that's a pretty basic one. I think you would agree, right? Didn't have to manipulate the formula, right? Okay, anyone still need that? All right, so let's look at this one here. How long will it take a jet traveling at 330 meters per second, okay, to travel 400 kilometers? Okay, Incidentally, 330 meters per second is the speed of sound. So this jet is traveling at Mach 1, the speed of sound. Okay. So I know V, because they told it to me, and they gave it to me in meters per second. So that's the speed, no direction. Okay, it was scalar. And they told me it's going to travel 400 kilometers. Why did I convert that to meters here in my givens? Right. My units need to match. Okay, I can't divide kilometers by meters per second or the other way around. All right, so I have to make sure all my units match. And it's way easier to convert the distance to meters than it is to convert meters per second to kilometers per hour. All right, because that's what we call a compound conversion. It's several steps. I'll still show you how to do it, but this is the easier way. All right, so now I've got to solve for t, because they asked me how long does it take. So v equals d over t. If I want to solve for t, it has to be top or bottom? Top. So to get it on the top, okay, what I'm going to do is move it to the other side. I'm dividing by t right now, so I'm going to do the opposite, which is multiply both sides by t. T cancels. All right, I want t by itself. What do I have to do with v? Divide, okay, because right now I'm multiplying by v, so to move it over, I would divide by v. All right, so t equals d divided by v. All right, now let's just double check. D is in meters, and v is in meters per second. So if I divide meters by meters per second, I'm going to be left with seconds, because the meters will cancel. All right, is that the units I'm looking for? You can always confirm whether you've done your manipulation correctly by dividing the units, okay, or multiplying, whatever. Put the units in, do that operation, and if what you're left with was the units for what you're looking for, you did the manipulation right. All right, so I'm going to go t equals my 400,000 divided by 330 seconds. Meters per second, sorry, meters per second. And this is in meters. All right. Okay, so 400,000 divided by 330. All right, it's going to take 1,212 seconds. Does that seem like a long time? Okay, it's actually not all that long, because there are 3,600 seconds in an hour. So it's a third of an hour, roughly 20 minutes. Okay. Everybody with me there? You wouldn't have to convert it, you just leave it in seconds. If you were solving this, don't convert it to hours or minutes, whatever you got. Unless this question specifically says how long in hours, leave it in seconds. Okay, so we've got 1,212 seconds. Okay, that's the toughest manipulation of v equals d over t there is. All right, I want you guys to try this one. I know. Is this exactly the same as the last one? Yes, it is. We're manipulating for time here. Okay, so we have the velocity, 9 meters per second north. Displacement, 650 meters north. We're looking for time. Okay, so v equals d over t. So I bring t over here and move v over here. Okay, and solve. So we've got our 650 over 9. Okay, so 650, okay, divided by 9, and we get 72 seconds. Now, do I need to put a direction on that? No, time is scalar. Here's why I don't have to put a direction on that. This was in meters north. This was in meters per second north. Well, yeah, that, and we just have to recognize that time is scalar. Okay, I can't say it's 72 seconds north. Time can't be north. Time just happens, whether I'm standing still or moving north. Okay, everyone follow me? Okay. All right, let's try this one here. Okay, give you guys a couple minutes on that one. Similar thing, okay? But remember, this one's got two parts. It's traveling up in the first part, down in the second part. Okay, this question is trying to trick you. It gives you up and down, and I left that little diagram there of the 25 meters on there because I wanted to see how many of you would remember that distance is scalar. Does it care whether you have moved up or down? Only how far you have gone. So, you went 80, and then you went 65. So you've gone 145 meters. Oh, sorry, 85 and 60. Still 145, right? I had it right in my head. Yeah. Okay. Okay. So it goes 145 meters in total. That's the total distance traveled. Doesn't matter whether you went up or down. Okay. So the total distance is 85 plus 60 equals 145 meters. All right. The total time is 30 seconds plus 20 seconds, which is 50 seconds. Average speed equals total distance over total time. All right, so that means we take our 145 and divide by 50. All right, we should get like 2.9 or something like that, right? Yeah, 2.9. 2.9 meters per second. All right, now, what if it had asked for velocity? Right, well, we would have to give direction, but it's not going to be 2.9 either. Okay, if I was asked about the velocity, I would need the total displacement over the total time. Here's where that diagram comes into play. I went 80 up and 65 down, right? Yeah, I keep getting that wrong. 85 up and 60 down, okay? Which means if I went 80 up minus 85 up minus 60, I get 25 meters left. I ended up 25 meters above where I started. Everybody with me on that one? All right, so my total displacement then is 80 minus 85. Jeez. Go home, go back to bed. 85 minus 60 over the total time, which is still 50 seconds. All right, so we got 25 meters over 50 seconds, right? And this is 25 meters which direction? Up. It's an elevator. Up. Okay, so that's going to mean 0.5 meters per second up. Okay. And quite honestly, guys, I put one pretty much like that on last year's unit exam. Okay? Simple a question as that. Calculate the speed, calculate the velocity. All right? Once in a while I put one on there, but I only ask for one or the other. Like I would have left it maybe like it was there at the beginning where it only asked for speed, and it would get a lot of people because I gave the directions and then asked for a scalar quantity. Right? So always make sure when you're reading the questions on a quiz or on a unit exam that you identify scalar vectors. Some people write S and V above quantities. Okay? Other people highlight in different colors. Okay, they use one color for scalar quantities, one color for vector quantities, whatever. But it's really important that you identify what type of quantity you're solving for, so you solve for it in the right way. Okay. All right. Now, this one is a bit trickier even. It's got 3 parts. Doesn't really make it a whole lot harder, it just makes it longer. So, I want you guys to figure it out. Okay, I'm going to give you a few minutes. I want the overall distance traveled, which is scalar or vector. Scalar. And then I want the average velocity, which is vector. All right, so I'm asking you to solve for one scalar quantity and one vector quantity in this question. Now, my recommendation here is this. Write out your givens separated into the 3 parts of the trip. It'll be easier to keep them organized that way. Okay, so write out your givens for each part. All right, so we'll do that part together here. In part 1, the elephants walk for 1.1 hours. So that's a time, 1.1 hours. Okay, at a velocity of 3 meters per second north. Okay, and in part 2, they walk 7 kilometers south. Okay, that's a displacement because they gave a direction. So I'm putting arrows over my vector quantities. Okay, and they do that in 1.5 hours. All right, and then they walk at 4.5 meters per second north. Okay, for another 2 hours. Okay, so we want to find the overall distance traveled and the average velocity of the elephants. So if I want to find the total distance they travel, I probably have to find how far they go in parts 1 and 3. Agreed? Because I don't have that, but I can find it. Okay, for the overall velocity or average velocity, I need the displacements, which I'm going to calculate, okay, in parts 1 and 3 as well. All right, so I'll give you a few minutes to figure that one out, and then we'll go over it together.